Yeah, so hi everyone, I'm Shang. Right now, I'm a staff engineer at Hubble.build. I'm also a Google developer expert in Firebase. So today, I'll be talking to you about how you can protect your back-end resources with AppCheck. So most of you guys are devs, right? So as devs, it's important to build products as well as to secure products against misuse, right? So recently you heard over the news, there's a lot of apps being compromised, right? Especially banking apps. So I hope that this session could give you some sort of insight as to how you as developers protect your app against attacks and other malicious use. So in today's session, we're going to go through these few items here. What is AppCheck? What are supported platform and providers you have? How can you get started in getting AppCheck installed on your applications? And how you can do it on other areas as well. So as developers, right, you build apps, right? It can be web app, it can be mobile app, it can even be APIs for third-party clients as well. So essentially, your job is to build all of these features that your customers would want, right? And let's say you have this really cool app that you decided you want to build that really serves some sort of function in the market, right? And let's say in your app, you use Firebase products already, or even your own products, or your own backend services. So in this case, for this example, you would have a Cloud Firestore for saving data. You might have cloud functions to run sort of business logic, and you might use cloud storage as well to store all your images or resources. So all of these Firebase resources, right, has to be secured usually with a few things. So most of the time, you would build your app with security in mind. So you will have a Firebase authentication or your own authentication provider, as well as security rules to safeguard your data from abuse or from unauthorized access. So most of the time, this would be enough in your app, right, to make sure that correct users are able to access your data correctly, or more accurately, the secure data that the user should be able to access based on the rules or your permission rules, right? So most of the time, this should be okay. But end of the day, let's say after you have done this and everything looks great, right? And for some reason, your app is really popular, right? So now everyone really uses it. It's viral over the place. Now everyone just downloads and install it. So everything looks fine. You are sure that your app is working well. You are sure that you are protected from unauthorized access by malicious users. Make sure your data are safeguarded with authentication and security rules. But then somehow or rather, some random guy somewhere will come out in the open and say that this app seems to be quite popular. Why don't we steal data? Let's take a look at how we can steal data from your app, or rather your data, right? So this hacker will come, will take a look at your app or your website and see what data they can collect. They might resell that data. So you have someone trying to gain access to your backend. So most of the time, since your backend is already protected by authentication and security rules, right? So your data should be secure, which is fine. But there are other concerns as well that you need to consider. So one of the few biggest concerns that we have is unauthorized resource usage, or what we call as we waste your resources out. So all these hackers will start to, for example, let's say you build an app, let's say a crypto app, for example, a crypto app that accurately calculates when you should buy or when you should sell, for example, or maybe you keep track all kinds of coin data like what is the current price and stuff like that. And now your app is really popular, but you have other people trying to copy you. So rather than getting the information from other sources, what they can do is that they can access your backend and get those data. If it's public data, that's even worse, right? Data that you don't have to secure by authentication or authorization. And all of these hackers can build their own versions of the same app and just access your app, access your data like that. So you're faced with a situation where now the attacker can do a few things. One of the few key things that they will usually do is billing fraud. So let's say your app is really successful, right? It hits maybe 1 million downloads, and you are of course paying for that traffic, right? But sometimes, let's say for some reason, you notice there are unusual billing usages, like maybe middle of the night, you see there's a spike. Why is there suddenly 10,000 connections going into my backend, downloading this data? And that can be what we call as billing fraud. So end of the day, when you get your bill, right, your usage bill, you will see that there's an extra spike of data of billing being charged to you because some unknown third-party network is stealing your information or connecting to your backend resources and stealing those information. So the other problem that we might have is the attacker can do phishing, right? So I'm sure most of you are familiar with the word phishing, right? You just don't fish in the class lah. Don't fall asleep in today's session. So here, phishing or impersonation is they impersonate your app as a legitimate version of the same app. So it presents itself as a real version of your app, but actually it's a fake one. So they can clone your app. It might look exactly the same, but it's actually not produced by you, the developer. So they can impersonate the app, send the app in the wild. Sometimes you will download via APKs or unknown market or unknown sources, right? So all of this can cause problems down the road when you're trying to track, why is my app suddenly doing things that it's not supposed to do? And of course, one of the other problems we have is bot manipulation. So this is more towards data that people scrape, right? Let's say you build a portal with some machine learning stuff that gives information about when is the price of crypto going to drop or going to go up. And that information, that someone tries to steal it to build their own, let's say, automated bot to buy and sell crypto, right? Or whatever you want to do. And we don't want this third-party unauthorized access to access all your data out of the client that you build, which is your app or your website, right? You don't want a clone of the same app coming out. Let's say you want to build a Lazada app, right? Let's say that you have Lazada. Now someone wants to build the same app, they call it Ladaza, right? Ladaza comes in, it doesn't need to keep track of all of the data, it just pulls data from Lazada. So you pull all the legit information from Lazada and then present it in Ladaza, and then people buy from there. So you as the owner of the website, owner of the data, you don't want third-party access to your data. So this is what we also consider as bot manipulation and stealing of your data. So in this case, you will notice that you have this missing gap in your security where now my apps are being exposed to this sort of threats, right? So how can we mitigate them? So down the line, if unfortunately, if your app is not that secure and these things happen to you, then of course now your business is not going fine. Right now you're getting charged more and more often for things that was not from your own app and all these unauthorized usages. So this is where AppCheck comes in. So the Firebase App Check has been around, I think last year, end of last year, from beta, but now it has graduated into general availability. So that means you can use it right now. So what does it do? So AppCheck protects access to your services by making sure that all the traffic from your backend, comes from your origin app. So this can be your mobile app, it can be a website, it can be API services, etc. So how can we do that? So earlier on, as we mentioned, this is how your general app will look like with the necessary safeguards already. But these safeguards, like I mentioned earlier on, is not enough. So our objective here is how can we prevent unauthorized access to your data, your backend data. If your data is already secure with, let's say, protected user credentials, right? What if the attacker uses the same credentials and try to access your data, but from a different app? So what can we do to prevent this problem? At the same time, this can also happen on non-Firebase resources on your own backend, which I'm sure most of you are doing that as well. If your own backend, you only want your product, in this case, your website, to access, for example, your APIs, right? You only want your website, you only want your app have access to your particular APIs. You don't want third parties to see your API request, create a duplicate copy. The token can be the same because the token, you can have a legitimate user credentials, right? When you log in to get the token that can be accessed by your backend client. So your backend client now is independent of your client, your front end side, right? Your backend. So that means any request that is legitimate will still be processed by your backend. But in this case, bad actors or those people who really want to mess you up will of course can spam your backend with these legitimate requests, right? So we want to prevent this from happening. So AppCheck is split into two categories. One is called App Attestation, and one is Resource Access. So Attestation here means that how can we attest or verify to make sure that your app comes from you as the developer and comes from the legitimate source. While Resource Access is to make sure that only your app or allowed applications have access to your data. So these are two important things to consider when building your app. So let's take, for example, how it actually works in the behind the scenes. So let's say you fire up your app with AppCheck installed. So the first thing what will happen is that your device will first verify with an attestation provider. We will talk about attestation providers later on. So what happens is that when you integrate this AppCheck into your phone or into your app, this is the first thing that happens. It will ask the attestation provider to verify my application. So once the attestation provider has done all the necessary work, it will then issue a token to say that, hey, this app comes from a legitimate source. I agree that this is mine. Therefore, I send you a token. So the token will be sent with a time to live. So this time to live is basically just an expiration time of how long this token is valid for. So with this token, right, will be attached to all the Firebase resources that you're using. So if your app itself is using Firebase Firestore, or you're using cloud storage or real-time database, all of this is attached to the request by default. You don't have to configure anything else. So your resource will now be, you can call your resources and it will include this token with the time to live, and Firebase automatically checks whether this token is valid. So after some time, your app will resend a new token request, usually at half time of the time to live token. So if the time to live token is set to 1 hour, half an hour before, we will reissue or request from the attestation provider for a new version of the token. So that way people can't reuse tokens that they manage to capture. So this time to live token is very specific. It's customizable as well. So let's say if you're building an app, for example, that needs to deal with real-time information or need to make sure that your apps are always true and genuine. Usually we do it for gaming apps, for example. You would put this time to live token as shorter amount of time as possible, but not too short because there's a delay between your app and the attestation provider. So this is to make sure that the traffic that you're sending is not spoofed or not replayed by the attacker, right? But if you're building a website, let's say you're building an app that is not as that does not have a lot of critical paths, or maybe you only need to send data maybe once in every few hours, then you can increase the time to live token timeout. So maybe some people can put it at 2 or 3 hours, then only we will request it. By default, it's always at 1 hour. So let's say, for example, the time to live token has now expired or somehow is unable to get the newest token, or let's say some random app that is unable to pass this attestation check, then it will be rejected by your backend. So what this does is that, let's say you have a clone of the same app by someone who managed to, let's say, decompile your APK and then rebuild the APK from scratch, and somehow people go and install it. They are not able to connect to our Firebase services because they failed the first check, which is the attestation provider. So that way, they are not able to proceed. The UI will look the same, but there is no data, right? So if you're not able to see data, the app will look more and more suspicious, right? So let's take a look at the supported platform and providers for different use cases. So If you're mobile devs, how many are mobile devs here? Few. Web devs? Okay, so I guess this crowd is for you as well. So if you're mobile devs and you work on cross-platform or native environment, it's supported on both iOS and Android. If you're web dev, it's also supported. Firestore right now still has some things to work out, iron out for AppCheck. So it's still an ongoing process. But these are some of the attestation providers that we have. So if you're just building iOS apps, you can use device check or app attest. If you're building for Android, you will use Play Integrity API or SafetyNet. So SafetyNet is being deprecated for Play Integrity API. If you are building websites, then you would use a reCAPTCHA or reCAPTCHA Enterprise. So I'm sure most of you are very familiar with the reCAPTCHA, right? So if you don't want to use any of these provided attestation providers, then you can build your own one. I would recommend you not to, because now you are exposed to different vectors of attack that you might not think of when you build your own custom attestation. So let's take a look at what reCAPTCHA version 3 for web actually does. So I'm just going to show you a demo of how you would set it up. And here, end of the session, you would see that there is actually no I am a robot or please fill in the blanks and stuff like that. So with web, what we want to do, the objective here is to make sure that people don't copy your Firebase configuration or copy your, let's say, your API request middleware or your request layer that you use to call APIs and try to impersonate your app. So let's go through that. So right now, this is Firebase console. So if you're not familiar with Firebase console, it looks like this. So to start, right, make sure you have an app that you have created here. So all I did was just create the add app, and you can just add the web app itself. Let me just zoom in. Right, so go to the AppCheck itself, and you can see all the APIs that we have. So right now for this demo, I enabled two. One is storage and one is real-time database. But let's go back and look at what we want to protect. So right now I built a simple website that actually pulls data from the real-time database. So let me just show you the app itself. So this was an app that we did for some demonstration and has some data. So all of this data is secured through Firebase authentication. So only login users can actually see this data. If you're not logged in, you're not able to see this data. So what happens now is that what people can do, right, if they want to clone or take your data, for Firebase point of view, what they can do is they can just go and check your Firebase configuration, right? So if you go and look at the data here, your sources, wait, where did the configuration go? Somewhere here. So let's say the person knows that this is a Firebase app, or if they didn't even know, let's say they have all the time in the world to actually go through your JavaScript, they should be able to find the configuration that you need to do to set up your Firebase app. So in order to set up a Firebase app, you need a few things, right? So if you're familiar with it already, you would have a Firebase configuration for your web app. So if you've done work with Firebase, you will notice that you will need to actually add all of this configuration in your client-side code. So all this configuration itself is actually public-facing. So none of this information is secret. So in a typical full Firebase implementation, right, you will actually have this in your public-facing JavaScript. So what it does is that it just establishes the connection to the correct Firebase project. But it depends on you to make sure you have set up the correct authentication and the security rules to make sure no one other than your users are able to access this data. So what attackers can do is that they copy this information and then they put on their own version of the same website. So they create a duplicate website, they put this thing and ask you to log in. You're able to log in because you're still connecting to the real Firebase project. But now what they can do is they can add fake stuff in the page, right? Let's say, oh, click here to get your free subscription. And then you click. Because you thought it's part of your data, you will notice that all your data is correct. Everything you have there is real, so people thought it's the real deal, but actually it's not. So with this information, they basically can connect to the legit version of your Firebase project. So if I go back to my project and look for it, I should be able to find it in the JavaScript. So let's say they somehow, so now this is public facing information, they're able to actually access this. Maybe too much. Okay lah, pretend you can see these long lines of text. So basically, oh, this information is public facing, which is fine, is correct. So what if they copy this and put in their own website? Now your app technically is connected to your Firebase resource, but it's not your version of app. So they can put ads, they can put whatever they want just to piggyback on your resource usage, right? So let's say this guy is more popular for some reason than yours. So everyone now access his website rather than your own website. But you are the person who are getting charged for all of this traffic because it's pointing towards your own legit Firebase project. So how can we set this up? How can we protect our app against these sort of things? So as I mentioned earlier on, it supports what do you call that? ReCAPTCHA, right? So the first thing we need to do is to generate a reCAPTCHA key. So here I already have an app. In this case, I call it the friendly chat. So of course, Google reCAPTCHA can be used to do a lot of things to make sure that you don't have any bot access as well, right? But we can use this as well as an attestation provider for your application. So if you create a new app on reCAPTCHA, you are given two keys. One is your public key and one is your private key, right? So take this private key, take this public key, and what you're going to do is you're going to add into your application. So let's say this is one of it. So what you need to do is, let me just put this aside. Go back here. So all you need to do is to include the AppCheck library in your JavaScript project. So once you add this in, all you need to do next is just to set up your AppCheck. So just initialize AppCheck and you put in the AppCheck provider key. So this key is the public key, not the private one. So end of the day, the users or whatever attackers, they can still see this key, but they don't actually can do anything with it. I'll talk about it why later on. So all you need to do is just add this key and you're done. All your Firebase resources now are being protected by AppCheck via reCAPTCHA. So this is an invisible reCAPTCHA, so there's actually no things that will randomly pop up, ask you to fill in or click which one of you is not a robot or which is a traffic light, right? Or which is a van, which is a mountain, which is a dog, which is a cat, right? So all of this is hidden away from you and the users will not know anything. So you're thinking like, how does this actually protect my app? I mean, if I just copy and paste it into a fake website, I'm still doing the same thing, right? It still executes the same, right? So this is where you will need to configure something on your Firebase side of it. So if you go to the App Check and click on your apps, you're able to find something called the all your apps are listed here. So here you actually can enable it as well. So if you notice, we have two providers. One is reCAPTCHA, one is reCAPTCHA Enterprise. So the difference between those two is reCAPTCHA, there's a limit as to number of verifications you can do. So for day-to-day usage, this is fine. But if your customer base is a few million, then you will need to get reCAPTCHA Enterprise to support a higher load. So here you need to do is add a secret key. So this secret key only lives in a secure environment, which is your Firebase console. So all you need to do is just paste your secret key that you got from the reCAPTCHA website and you're done. So when an attacker tries to load the app, which is what I have right now, so let's say I don't include this. Or rather, I include this because now I'm the attacker, right? I somehow managed to get a copy of your source code, somehow already have your public information or your public keys, and I try and test it out. So this is the application I'm running right now. So here, let's say, so now the attacker has launched his website. This website contains the same credentials, same configuration as your original website. And you will notice now he's able to log in because they still have the correct login credentials because they are sending this link to your real users. So your real users will naturally have their own username and password, right? So they log in normally, but they now don't see data. So why they are not able to see data is because we have enabled AppCheck. So now they're not able to do any weird funny stuff like scrape your data or try to bypass your front end layer to access your back end stuff. And we can take a look at the data that is provided to us. So by clicking on this, you actually can see this graph that appears. Not very nice. In this period, I didn't do anything, no data. But for this demo, only you will see some data appearing. So there are 4 categories of data you can look at. It will tell you that how many % of your data is valid requests that come from your original website. So in this case, this is the original website. And this is the same source code that I deployed as well as the fake one. So you can see here, it will tell you a few things also. It will show you that verified invalid requests. So these are where the AppCheck token has failed or they are bad users who are trying to access your app. And of course, we also give you information about which clients are outdated or using an older version of the library or using an older version of the key, which you invalidated if it's somehow the user able to get your private key. But basically, all of this information is listed for you. So now you know who is trying, what details are happening behind the scene. So what's great is that now these invalid requests cannot go through your resources. It can't even go through the security rules layer. So they're immediately blocked at the gate. So you don't get charged this 30% usage because these are invalid requests. So if you build a app like you use Puppeteer and then you use her Jasline's Chrome recording tool, hey, actually your Chrome recording on the real website also can take our data, right? But end of the day, right? But let's say you record you build a fake website and you run the Puppeteer recorder to, let's say you want to scrape data, you want to see what data is available and you want to scrape, it will never pass because all that's being presented is an empty screen. They don't have this data because you are not from a verified origin. You're from a random website which reCAPTCHA is not able to determine correctly and is not listed in your AppCheck itself. So that's how you can protect it against abuse, right? So now you're happy, you're making sure that only your app can see your data. No one can actually go and copy unless they manually copy and paste that. But now there are no bots who can pull your data from the back end and compile their own version of the same data because it's protected by AppCheck. So setting for Android is not that different either. So in this case, you will need to do it in here as well. So what you need to do, if you are not familiar with Firebase, is to create a new project. So you just go and add an app here. In this case, I already added an Android version of the same app, right? And then, of course, you need to generate your fingerprints, right? So if you're familiar with Android development, you would use your signing key to generate this SHA-2 and SHA-1 values, so that these are public values as well, so that you know what your signing key is connected to your private key is associated with this hash value. So once you add this SHA fingerprint, this basically tells me that only my app with this signing certificate will only match these values. So any other app, even though they decompile it, right, and recompile a new version, your SHA signing key will be different because they have no access to your signing key. Unless somehow you leak out your secret key, then I cannot help you. But yeah, so if you keep your signing key or your private key in your GitHub repository, you better delete the project and build a new one, right? So with this fingerprint, it's not enough. We of course need to set up our attestation providers as well. So earlier on, I mentioned that one of the few attestation providers for Android is Play Integrity and SafetyNet. So if you go, so what we are showing you right now is for SafetyNet. So SafetyNet itself is easy to configure. You just fill in your SHA fingerprint details and time to live, and you just add the appropriate client libraries on your Android project, and you're fine. It's that simple. So with that, all of your Firebase resources automatically have this signing key token that is being sent. You don't need to do anything more. So the same goes to iOS as well. And let's talk about something that you most likely is your use case, is that if you don't use any of the other Firebase products, you would use your own backend services, right? How many of you are actually using Firebase backend? Firestore, real-time database? One or two? Great. Okay. But most of you are using what? AWS, is it? Huh? Okay. We don't have a Google Cloud right here, so maybe the person can come and pitch up. But basically, most of you are using third-party resources, right? So how can you use Firebase App Check with third-party resources, even though if the company starts with an A, right? So we can do that quite easily as well. Oops. I'm going to just skip this one. I'm messed up. Yeah, okay. So for custom backend resources is pretty much the same. Of course, now your app itself will connect to the app will now connect to attestation provider. In this case, depending on what app, right, Android, iOS, or web, and it will generate the token. Now, your token needs to be sent to your backend, but your backend does not know what to do with this token. I see this token, and then I'm supposed to do something with it to make sure that it comes from a real resource, right? So what it does is, if you configure it correctly, your backend should accept it wholeheartedly without prejudice, accept the token, and it should process your requests. So let's take a look at how you would build this on your backend. You can see, right? Except for the comment. So here, what we have is that, yeah, if you can see the comment, then salute to you. You must have Spider-Man eyes or something. But basically, what this does is, this is a Express.js app. So it's your backend code. It can be in Java, it can be whatever, but this is simpler to understand. So this exists in the Express middleware. So before requests are hitting your own backend, it does this check first. So the first thing that we do is that we check for the Firebase App Check token. So you have to make sure that you're sending this token in every of your API requests. yourself if you're using custom your own backend, right? So typically you will call an API anyway on your front end, and you have to make sure you include the X Firebase App Check token. So as the backend, your job is to reject immediately if you don't have this token. So let's say a random person or the bad actor comes in and tries to access your data by calling it on Postman or whatever script they have. They don't have the AppCheck token, so they are not able to proceed this step. So now your backend will immediately reject all of this as unauthorized. Let's say, for example, the person actually receives an AppCheck token. So now maybe the attacker decides to just randomly fill in the value. He guessed that X Firebase App Check is needed for some reason. So what you need to do is that once you receive the token, you need to verify it's actually real. So what you need to do is to call the Firebase admin SDK and then use the AppCheck to verify the token. And if this, what happens here is that now Firebase admin will talk to the attestation provider on your behalf and say that, hey, there's a request coming in. It wants to verify itself. So you give this token to the attestation provider, then it will check. It is valid, you just proceed to your middleware as normal. And then after that, you will do your own authorization check, your OAuth2 check, or whatever checks that you have in place in your current company or your current product. And it should just work normally. So this is how it will look like on the front end side. So if you're writing your you're writing an Angular app or a Next.js app or whatever JavaScript app you have, you will need to call the Firebase App Check library and include the token as well. So you just include this call and wait for the token to come back, and then you include it in your future API response. So this inside the middle layer, the middleware of your front-end API request layer. So you just add this in, and now your backend resources will include this AppCheck token. So this is a Java example of the same thing. So yeah, it's the same. This is the what do you call that? This is the iOS version of the same thing. No, this is Kotlin. Yeah, so you will do the same thing. So once that's done, right, once you're ready, added all this configuration in, now your product is much more secure, right? Now your bad actor is not able to penetrate into your app, because with AppCheck now you defend against fake apps. So what it means is that now you as a developer can make sure that the app they install comes from the marketplace. So that means, let's say you produce an app, let's say you produce a banking app, right? And somebody installs a fake version of the same app. What you can do right now is to check. We realize what the check will do is that they will realize that all traffic is own source. And you can immediately show a prompt to the user, hey, this does not seem to come from a legitimate app, right? And then you can let the users know it's fake. And of course, this protects against phishing as well. To make phishing more convincible, you would show users some real data that is associated with your account. With this, now the attacker is not able to get information related to your account anymore. So you're protected against phishing as well. And it also safeguards your resources. So now bots or random stuff that is trying to pull your data without a client or through an automated process is not able to do so already, because they need to attest, but they're not able to get that token. And this, of course, in turn helps with only allowing your trusted origin. So in this case, your apps originate from the marketplace, your website originates from the same domain itself, and stuff like that. Yeah. So with AppCheck, I hope that you're able to understand or get started in safeguarding your apps against these bad actors. Thank you. Any questions? Him first.
Okay. My question is, like, how do you really put the origin? Like, where do you specify the origin, especially in the custom that you show us just now?
Okay. So in the custom itself, you will notice that the backend's job is just to validate the token, right? But it's you as the front end to attest to a provider. So you will still need to configure. Hold on now, let me think. That's a good question though. So wait, so your question is how can you make sure that the your website is coming from the correct origin, right?
Yeah. So basically, what I can do is like create sort of API and create the correct, like connect to the current origin and take out the token from there and put it in a custom, and there I get the data as relay. Yeah.
So basically you're saying that, so is the website fake or not?
Yeah. So what I'm saying is, let's say I have a fake website.
Okay.
And then I make like in this fake website,
Uh-huh.
what I do is I call the origin, like the main site, and take the token from there and put it in the fake website.
Okay.
And make the connection go through. Because I already have the valid token, is it?
Yes, so in order to get the valid token, you only can call it through the SDK. So what the SDK does, it does the attestation on your behalf. So in web, you're using reCAPTCHA. So reCAPTCHA actually contains, you have to set up the origin domain. So what happens here is that if you somehow you still cannot access, you're not able to get the token because your current domain does not match the origin domain. You are requesting to get the AppCheck token through cross origin, so it will fail.
Okay, can I rephrase?
Okay.
I have a valid website. Okay.
Yes.
I have valid token.
Yes.
I redistribute this token into
And
other websites.
yes.
Exactly. It is valid.
Okay.
Exactly.
So that's where the time to live come into place, right? So let's say your how would you distribute the
Okay, every half hour I get new token.
yes on your legit website, right?
Yes.
Correct.
And same for fake website.
And send it for, like use it in a fake website.
Yes.
Because like now you cannot make sure that I'm calling from unknown origin, is it? Because I have a legit token.
From the from API's perspective, yes, it says that if it's really a valid token, yes, it will pass. But the problem is getting the token in the first place. Like you mentioned earlier on, your real website now is generating the real tokens, but somehow your fake website is able to snoop and take that token out.
Because I saw like in the backend, or like you are reading the token from the header itself.
Yes,
So
correct.
it's accessible, is it? Yes.
The token is accessible. The header requests is HTTPS, right?
Yep.
So technically your headers you cannot see your headers, right?
I can read it.
You cannot read it through a man in the middle, right? Because it's HTTPS, even your headers are encrypted anyway, right?
I mean,
Let's say for the worst case scenario, you somehow have a malicious extension somehow that is installed on your browser. There's always reading an AppCheck token on your behalf, right? On, let's say, on the real website. Yes, I agree that this case can happen. With that token, I'm not sure actually how would we resolve this problem.
we need to test it out first.
So AppCheck just make it harder to copy.
Yes, it's not a foolproof solution. End of the day, it's not a foolproof solution. Sooner or later, it's a cat and mouse game, right? See who is the better one at gaming the system, right? So it's better than nothing. Basically, there are still areas where it could improve. So they are constantly trying to figure out this. That's why I also don't recommend you to build your own custom attestation provider, because you might lose some of the use cases or some of the vectors that could easily be uncovered, right? So that's a good point as well. Right now, for your use case, I think it seldom happens. If somehow a person is snooping in the middle, I don't think they can get the request headers. But if it's from your origin and you are the devs, of course you can see your own tokens. But it's hard because this will actually invalidate everything else that people have done over the years, right? Your authorization headers are always included in a legitimate request. So if you already have the ability to decrypt the request headers from any other origin, you basically have the same problem. So it's more of the problem with why HTTP headers, how are you able to get the clear values of the HTTP headers from other origins? That's the bigger problem here. So in this thing, we are assuming that the headers are always secure, right? So yeah, it's not a foolproof solution. So yeah, I think it's a continuous game as usual, right? For security. Yep.
Can you see the list of API that make malicious requests? Just now you show the graph, but can I see the?
Oh, that's a good question. No, I don't think so. I think it's a good way we can feed back to the Firebase team as well, is to show the list of origins that are fake, so we can whitelist, we can blocklist them faster rather than hitting the attestation provider. Yeah, but that's a good feedback that we can give.
But you can see the unauthorized request, but
You-
you cannot see the origin.
You cannot see who is
Yeah.
doing the unauthorized request. You only can see there are unauthorized requests coming in. Any other questions? I have some pins with me. I think Firebase pins. I have Firebase pins, and I feel like I'm a salesperson right now. But I have Firebase pins and Firebase so-on badges on your jacket. So I'll let you choose one now. Yeah, just choose one of.
Okay, I will take.
Okay. Yeah.
Why can Firebase App Check not protect?
Not protect. It cannot protect whether you earn money or not. I mean, it can, good question.
All question is good,
All question is good. Okay. What can it not protect? What can it not protect? What can it not protect? Let's see. If somehow you face the same situation, what he mentioned, right? If somehow your browser is vulnerable to this snooping request, you will still have the same problem. If you somehow manage to perform a man-in-the-middle attack as well, some of the providers, actually there's a way to prevent man-in-the-middle attacks included, but I didn't cover because it's quite technical. But let's see what ways is it not protecting against. So one thing for sure is that it is not a surefire way to block. So that's explained clearly in the documentation, is that you should not use this as your single defense against attacks. You should always add your own other stuff to include, for example, your origin as well for your HTTP request to make sure it comes from the same origin. Yeah, but right now I can't think of any right now. Yeah.